Hello and a warm welcome to this edition of Productive and Effective Demand Management. Today we're going to take a look at the ErlangCalc software. My name's Peter Loader, I'm the owner of PL Insights and I'm also the author of the ErlangCalc software itself. You might be wondering, well, why have I developed this software and indeed this demonstration of it? Well, to be honest, it's all happened a little bit by accident really. I'm in the process of creating a whole set of educational videos under the working title of Productive and Effective Demand Management, and as part of that I wanted to try and explain some concepts using the Erlang approach. However, when I had a look around on the internet at some of the freebie versions of Erlang that were available, none of them really seemed to fit the bill. Many of them simply didn't look very professional. I'd certainly not want to be standing up in front of a chief exec presenting results in it. And some of them just seem to make it rather complex. Lots of Greek symbols knocking around, which we don't really need to worry about these days. And perhaps most importantly, none of them were really aligned with the concepts that I wanted to get across. So then I thought, well, could I create an Erlang calculator myself? I like to think I'm a bit of a whiz with Excel, albeit not with Visual Basic. I used to let my colleagues handle that side of the business. But then that led me to think, well, most of my customers aren't actually allowed to put Excel spreadsheets that contain macros onto their computers because IT departments fear that there could be some malicious code hidden within those macros. So I wonder whether it would be possible to create an Erlang calculator without the use of macros, without creating an add-in. And well, I like a challenge, and this is the result. An Erlang spreadsheet, an Erlang calculator, written in Excel that doesn't need macros or add-ins, and I'm also quite pleased with how it looks, but you'll have to make up your mind on that yourselves. Take a look. Conscious that some viewers may be new to Erlang, in the introduction, I shall explain a bit about the history of Erlang and what it's for, and then I shall move on to explaining what ErlangCalc is and how it can be used. The demonstration itself is split into two parts. In part one, I shall use ErlangCalc to demonstrate the principles of Erlang and the ErlangCalc software for a single hour of demand. In part two, we'll see how those principles are applied in the software to look at a whole week of demand, and indeed different weeks of the year. We'll see, for example, how it can be used, how well different shift patterns will respond to a demand profile that varies by hour of the week. What do we mean by demand management? Well, I deal with the term demand management in one of my other videos, but for purposes of this one, we can define it as the capability of an organisation to respond to and deal with requests for products and services. Two of the criteria for judging whether an organisation is managing demand well, and which are relevant to ErlangCalc, are first of all the timeliness of response to such requests, and secondly the cost of responding to them. So generally, if we can respond more quickly to our customers, we're likely to get a better reputation for good customer service, and clearly if we are able to do it at a lower cost in the private sector, we're going to make more profit. In the public sector, we're going to save the taxpayer money. Critical to achieving these goals are getting the resource levels right. If we don't have enough resource, there'll be delays in responding. If we're using too many resources, then the cost will be higher than it needs to be. In theory, calculating the number of resources ought to be straightforward. There's a simple formula, again I cover it in one of my other videos, but we can think of as the resource required from a simple calculation of the total amount of workload divided by the number of hours we've got available. So workload can be calculated by multiplying the volume of demand by the unit process time, and by net hours worked we mean the contracted hours that somebody's meant to work less any hours that we lose, which can be things like hours spent on breaks, dealing with admin, but also abstractions for sickness, leave, etc. So that sounds straightforward, but there are complexities. Often people have got more than one work stream to deal with, and these may have different process times. Net hours, as I've inferred there, needs to consider whole shift losses like sickness and leave, and in shift losses like breaks and admin and other such tasks. And resources probably can't run at 100% utilisation all of the time. We need a bit of downtime to recover. That doesn't even take into account other complexities such as when demand is random and perhaps seasonal, so more demand in the summer than in the winter or vice versa. Contact centres are an obvious example of this type of behaviour in a process. In the example of one day's demand that's shown on the chart on the right, the average demand, shown as the blue line, is 12 calls per hour. However, the actual number of calls received in any of those hours varies between 4 and 20, and this is shown by the orange line on the chart. If in that example each call takes 20 minutes to deal with, then the total workload, i.e. the number of people required to handle the calls, varies between over 6 to fewer than 2. In the chart on the left, the mauve line shows the effect if we employed 4 people to handle that workload. We can see that in some hours they would be twiddling their thumbs some of the time, but in other hours they would have too much work on and queues would build up. If we didn't ever want any queues, we'd probably need to employ 7 people to be certain of doing that, but can we afford to do that? Further complexity occurs if the number of calls that are expected in each hour of the day and the week varies. So in many contact centres, demand in the early hours of the morning will be a lot less than it will be during the day. Some call centres experience peaks around lunchtime as people try to call during their lunch breaks. There may be seasonality in the demand. It may not be possible to easily adjust staffing levels by week of the year to match that seasonality. This type of workload fluctuation isn't just found in call centres. We can see similar patterns in areas like instant response, such as the emergency services and the vehicle recovery, like the AA. Other vehicle recovery services do exist as well. Healthcare services like GP appointments, accident emergency, radiology, all experience that random fluctuating demand. Front offices, like when we go into a bank or if we want to use a cash machine. Supermarkets, barbers, these all are confronted with this unpredictable varying demand. The Erlang formulae are designed to work out how much resilience we need to build in to our resource calculation to allow for these fluctuations in demand, and it allows us to predict the typical customer service measures that we find, i.e. managing to handle X% of our demand within Y minutes of waiting time. The Erlang formulae are used to determine the staffing requirements in these variable demand and workload situations. They were invented in the 20th century by A.K. Erlang and C. Palm. You may come across the term Erlang in a call centre context, and it's 60 minutes worth of calls. So what do we mean by that? Well, if we had 6 20-minute calls in 1 hour, then that's 120 minutes worth of work. 120 divided by 60 is 2, so that would be 2 Erlangs. It can be thought of as the number of people we'd need to deal with those calls if they were 100% busy. There are 3 Erlang formulae. Erlang B is the probability of calls receiving an engaged tone when there's a finite number of lines. We don't tend to use that one too much now because it's not normally a constraint. Erlang C is the probability of a call waiting and can be used to calculate the number of agents required to achieve a desired service level. And Erlang A is the likelihood of a caller abandoning given their willingness to wait. It's Erlang A and Erlang C that have been built into the ErlangCalc software. These formulae, you can find them on the internet. You can also find, as I've said, free bits of software that include those formulae. Normally those use macros, and the formulae are widely used in workforce management systems, albeit they do have some limitations. I'll touch on those a little bit later towards the end, but I'll also touch on them more widely in some of my other demand management videos. So, given these other calculators already exist, why have I written a new one? Well, sometimes you actually just want a simple Erlang calculator rather than a whole workforce management system, which, to be honest, would be a bit of a sledgehammer to crack a nut in those sorts of scenarios. All I wanted to do was to illustrate some queuing concepts, and I just wanted an appropriate tool to do that job. Workforce management systems are not really designed for strategic options evaluation. Sometimes you don't just want to work out how many people you need to roster for next week. You're trying to evaluate different duty systems, different shift patterns, and their fit over the overall demand pattern across a year. And with some of those workforce management systems, it's difficult to do that sort of offline modelling on the effects of different forecasts, different demand levels, etc. So in those occasions, maybe a slightly different tool designed to tackle a slightly different problem is more appropriate. As I've said, other spreadsheets, some of them free of charge, can be found on the internet, but what I found was that most of them seem to look very professional in terms of how they appear. I'd not fancy standing up presenting the results in front of a chief exec using a bit of software that looked like that. Many of them require macros to be enabled, or sometimes they use add-ins to enable them to be operated, and these are barred in many organisations due to the threat of those containing malicious code. Often these bits of software are standalone and little thought's been given as to how we get information into them, or indeed how we can extract the outputs into other software where we might want to do additional processing. So ErlangCalc aims to overcome these issues. It's got a menu-driven interface to help you navigate around the software. There are no macros or Visual Basic, it's not an add-in. You can just simply copy the Excel spreadsheet onto your computer in the way you would with any other spreadsheet. You can even send it via email, it's not that big. And it also provides some additional tools to help with the data exchange and scenario management. From my personal point of view, and I think this could be applicable to any practitioners looking to adopt my method of thinking in my wider video set on demand management, the way it operates is consistent with the demand management principles outlined in those other practitioner videos and with other demand management software that's going to be coming along shortly from PL Insights that underpin those videos and that I'm making available to people to buy as well. So, starting to get into the detail, what is ErlangCalc? It's got two main capabilities. First of all, if you plug in the expected resource that you're going to have to service a given amount of demand, then it will calculate for you what performance you can expect in terms of calls answered within target response times and abandonment rates. If you want to know how many resources that you need to achieve that sort of service level, then again, that's what it will do for a given level of demand. So it will tell you if you want to achieve X% of calls answered within Y minutes and have a maximum abandon rate of Z, then it will tell you how many resources you need by each hour of the week to achieve that. It's all contained within one Excel workbook. It's got a number of components to it. There's a single Erlang calculator, which just provides outputs for a single time period. It's got a weekly calculator that gives you outputs hour by hour for a 24/7 week. You can enter annual weekly demand and select which week you want to run through the software. It's got the capability to compare different scenarios, both under the single and the weekly calculators. And there are some extra tools as well, that the main one being something that allows you to take a list of planned shifts and convert that into a 24/7 grid of how many resources there are going to be in each hour of the week. And that's particularly useful when we're looking to test out different shift patterns and their propensity to deal with demand in an efficient way. As I've said, the workbook doesn't use macros, Visual Basic or add-ins. You will observe that some of the cells are hidden and protected. However, you can copy the outputs from ErlangCalc to other software, or indeed link the worksheets with within ErlangCalc to other Excel worksheets, and you can similarly go the other way. So if you want to bring your data in from other spreadsheets, you can link the inputs of ErlangCalc to those other workbooks. The demonstration itself is split into two separate videos that you should be able to see on the PL Insights YouTube channel. In part one, we use the ErlangCalc single hour calculator to familiarise you with the software and to illustrate the main concepts behind the Erlang formulae. In part two, we use the ErlangCalc weekly planner to determine optimal staffing profiles and test shift patterns that provide a better match to when demand occurs. I look forward to seeing you there.